was definitely.
All right, I think we're on now. Okay, so this is section 5.1, solve systems by graphing. Now, just as a reminder, when we did section 4.4 and 4.5, what we did on Tuesday and Wednesday this week, that is stuff that will not necessarily be on one of our assessments. It will be on the state test, and I'm going to ask a couple questions on it on the exam. So you will see it on the exam, but that's a positive correlation. The amount of times Henry balances in his chair and the amount of times he will crack his head open. I would say that is a positive correlation. Not necessarily causal.
The chance.
Right, the chance that he will. Positive correlation, not necessarily causal, but positive correlation. Let's not do that. Let's decrease our chances there. So 4.4 and 4.5, not necessarily on any of our assessments, but it will be on our exam in the state test, definitely. I think we saw yesterday all those different types of questions that they're going to ask you about R value and whatnot. Now, here we're going to get into chapter 5. Now, we are not going to get all the way through chapter 5 by the end of the semester. Now, we only have like a week and a half left at the end until we have to start reviewing for the exam. So, we're going to get the first 3 sections done before the exam. We're going to do 5.1, 5.2, and 5.3. And it's all about systems of equations.
You know how our exams are 20%
of the semester?
So
Yeah.
On our report card,
You'll see it as a separate column.
Okay.
Yeah. So chapter 5 is all about systems of equations and how we solve systems of equations. So first off, what the heck is a system of equations? I guess I got to hand out the guided notes too, but this isn't even on your guided notes, so I'll do that while I'm talking here. So by definition, a system of equations is a set of 2 or more linear equations with the same variables. Like, for example, they have an example shown there for you guys. It's just basically 2 equations on the same graph. Can it be more than 2? Sure. The more equations that you put on a graph, the more complicated it gets. But it can be at least 2 equations on the same graph. That is what's called a system of equations. Now, what we're going to learn over the course of the next 3 sections is how do we solve a system of equations? How do we solve a system of equations? With math, that's true. But we're going to learn actually 3 different techniques. 3 different techniques of solving systems of equations. Honestly, guys, this is what a visual representation of what I'm talking about is basically this. If I've got a graph, let me bring up a graph real quick. Okay. So if I've got this graph here, a system of equations would just look like this. I've got one line, and I've got another line. Okay? That is a system of equations. You want to know where the solution is? Where they meet, where they cross. So this is the solution to this system. Now, we're going to spend the next couple of sections over how do we find that point. Because I'll tell you right now, just by graphing it, am I able to tell exactly where those 2 cross? No. I can estimate, and we will do that too, I can estimate something like -3 comma positive point, negative 3.75 comma positive 0.9, something like that. We can estimate where it is, but we can't tell for sure. We would need more of an algebraic way to do that, which is what we'll talk about in sections 5.2 and 5.3. But if I ask you for the solution of a system, I'm asking you for an ordered pair. I'm asking you for a location. I'm asking you for the point of intersection. Now, just like we did with equations, we're going to learn how to see if our solution is correct. So think back to equations. If you get your answer, how do you check your answer? You plug it back in. We're going to do that exact same thing here with a system. Everybody do this along with me. I somehow found the solution 2 comma 5. The x value 2, the y value 5. Somehow. I don't know how. But we somehow found the solution 2 comma 5. Let's see if 2 comma 5 is a solution. Let's take a look at equation 1. Let's plug in 2 for x. Let's plug in 5 for y and see if it checks out. Is 2 plus 5 7? Yeah. So it checks out for the first equation. Can we stop? No. We have to check it for the second as well. Let's check it for the second equation. So we have 2 times 2 minus 3 times 5. Is that 11? Let's check. 2 times 2 is 4. 3 times 5 is 15. Oh, sorry, negative 11. I was going to say, I think this one should have worked out. 4 minus 15 is negative 11. That checks out. So is 2 comma 5 the point where these two lines cross? Yes. Yes, it is. Because I see that this is a solution to both of these equations. So we say, yes, it is a solution. Yeah, this is a yes or no question, but if you don't have the work there to back it up, I won't take credit for it. Why don't you start plugging it into the second one? Take your second example there. Looks like it's a negative 2 comma 0. Start plugging it in. See if it is indeed a solution or not. Plug in x for x, plug in y for y. See if it works for the first equation. Stop. Then see if it works for the second equation. Plug in x for x, y for y. See if it works. Like here's equation 1. 0 is equal to, equation 1 again. 0 is equal to negative 2 times negative 2 minus 4. Does that check out for equation 1? Yeah. Let's see if it checks out for equation 2, though. Is that a true statement? No. So is negative 2 comma 0 the point where these two lines will cross? No. I know that I got this wrong. I have to go back and do something different to see where my solution is, because I know it's not negative 2 comma 0. See, what I'm teaching you here is how do you check your answer? My answer here is just a no.
You don't have to explain it or anything?
No, the work is the explanation enough. Yeah. Questions about that? So again, that wasn't really showing you how to solve the system. That was just showing you how to check to see if a solution is there, if that is a solution. All right. So let's talk about our first method of solving systems. The first method that we have is by graphing. Now, we've spent a whole chapter on graphing lines. And we're going to do the same type of thing. We're going to graph the lines and see if we can tell where the solution to the system actually is. The nice thing for this one that I gave you here, man, I gave it to you in slope-intercept form. You say, thank you, Mr. Labrick.
Thanks.
You're welcome. And you graph these two lines. Let's graph the first line together here. I'm going to graph line 1. Well, line 1 has a slope of negative 2 and a y-intercept of 5, right? If it's a slope-intercept, it's really easy to tell the slope and the intercept. Plot the 5, slope with negative 2, down 2, right 1. Okay. Now, when you're graphing, you want to make enough points to fill the graph, because we don't know where our second line is going to end up. And we want to be very sure where that point actually happens. And let's take our second line here. I'll put it in red. The m is 4. The b is negative 1. So we plot the negative 1 and we go slope 4. Rise 4, run 1. And look at that. And as soon as you see where the intersection point is, you don't have to make any more points. You just graph your line through it. And then you say the solution to the system is 1, 3. 1, 3. That's my answer. The answer is not the graph. The answer is the coordinate. Where do these two lines cross? These two lines will cross at the point 1, 3. Okay?
So you don't have to say the other part, where it's like m equals 4.
No, that's just showing you how to graph it. Now, what happens if it doesn't come out so nice? Well, then you kind of have to estimate it. And at that point, estimation is not great, right? If it doesn't come out as a nice, neat point, you're going to have to use some other method to solving the system of equations. Okay? Now, the nice thing for you guys is that your state test gives you a lot of systems of equations, but there's this nice little button on the state test that you can click on, and it'll bring up the Desmos Calculator. Have you guys used the Desmos graphing calculator before?
Yep.
Some of you have, some of you have not. Let's all get out our computers and I'll show you what I mean. To find the Desmos calculator, again, on your state test, it'll be a button for you. I actually give you that option when I give you the assignments we do in the Big Ideas website. There's a little button there for the Desmos calculator. But I would just suggest Googling it. If you just Google Desmos, Desmos, it's pretty easy to find. So if I come over here and I say Desmos. Yeah, it says you want to click on the graphing calculator, not the scientific calculator, but the graphing calculator. That's the one you want. That's the one you'll have on the state test. That's the one you want to practice with. So everybody navigate to the graphing calculator. I'm going to click here. It should look like this. And this is what the box that will open up with, like on your state test. This is what it'll look like. Okay, a smaller version, a shrunk down version. But this window will open up. Now, you want to see the beauty of this Desmos calculator? Let's take the equations that we just used, the one that we just graphed by hand, and let's plug them in. Just for your you can see it on your guided notes there, so I got my paper out. It was y is equal to negative 2x plus 5. So you're going to type in y is equal to negative 2x plus 5. Look at that, graphed our line for us. And I want everybody doing this. I want you to practice. And then you just enter down to get a new line. Y equals 4x minus 1. And look, they cross. And all you have to do is literally just click on that point and it tells you exactly where it happened. Yes, the state test allows you to use this on their state testing system. That's like, oh, wow. You just made all of those problems really, really, really easy now. Okay? I want every time you see a system of equations on your state test, I want you using Desmos. I want you to forget about the other things like substitution elimination, which is what we'll talk about sections 5.2 and 5.3. I want you to use Desmos. Now, that being said, there have been questions on there that say, okay, how would you solve this using substitution or using elimination? So you have to know those techniques, but if it doesn't specify, I want you using this thing because this is super easy to use. So let's get to it. Let's do the bottom 3 questions together here. Okay. I'm just clicking the X on those to get them out of the way. Y is equal to X minus 2. Everybody type it in with me. Y is equal to X minus 2. And then Y is equal to negative X plus 4. And I click on that. 3, 1. Appreciate how much time and effort this is saving you. You know, think about that. This is saving you a lot of time and effort. So 3, 1 is your answer for the first example A, example 3A. Let's take a look at example 3B. Now, be careful here. I want everybody practicing typing in these fractions because it can get a little tricky. Y is equal to, now I do 1 divided by 2. Now, if I put an X in there right now, it's going to put the X into the denominator. Watch. If I just hit X, it's going to look like that. Ladies and gentlemen, that is not a line. Divided by. Do the slash.
Whoa, if you keep clicking X, it does a little dance.
Does a little dance. Well, let's see.
It does.
Do a little dance. I know. Okay, so 1/2. Now, how do you get out of the fraction? You just hit the arrow right button. So 1/2, then x plus 3. And then I'm going to enter down y is equal to -3 divided by 2, arrow over, x minus 5. The divided by, the slash.
Our homework is really a Desmos worksheet, so we can use it.
Yeah, it's going to take like 2 minutes for this. There are a couple where you graph by hand. Questions about that? Let's do the last one then. Example 3C. Now, notice how everyone that we've tried to do has been into y equals. Desmos, now listen to me. Desmos used to make you put it into y equals, but guess what? They changed their system. You don't even have to do that anymore. 2x plus, oh, not even typing. 2x plus y equals -6. And then 3x plus, minus 0.5y equals -7. We get our new couches.
They're doing couch races?
New couch.
I like the colors of those ones.
Yeah.
We should all go out there.
Are we sponsored by like IKEA?
Are we sponsored by IKEA?
Where do we get the furniture? It's so colorful.
I don't know. All right. So, your homework. Your homework for tonight. I'm going to hand this out right now because that's the end of the guided notes. Your homework for tonight is, everybody look up here, please. This is double-sided. 2 graphing by hand, where you see the graph like provided for you. I want you to draw in your graph. Could you use Desmos to check your answer?
Yep.
Of course.
Or to kid your answer.
No, just to check your answer.
No.
I was nice to you. I gave them both into y equals. Front and back. The other 4 on each side, you can just go literally straight to Desmos. Okay? For both number 4s, I don't know why it auto-numbered and it started back over on the back. I don't know why it did that. But for both number 4s, it comes out to be a messy number, like it doesn't hit at a nice clean point. I want you to estimate where it would be. Okay? So go ahead and you can use the rest of the time. 15 minutes. You should all be getting this done in class today because this should not take you very long.
Bro, why are you guys ground the papers with that? You guys are like work.
Oh yeah, when he's handing out tests.
Yeah.
It's like this. He doesn't want anyone to see your score. He doesn't want anyone to see your score.
It's like this.
I have no idea what was going on. I was just talking to Mr. Lumber
You have
and
like
I
that?
walked out and they're like,
I use ours for this one.
Yeah.
If you need go on
Did anybody not get a worksheet? Okay. Turn off the video here.